So the next major topic we want to talk about is gravitation. Gravitation is pretty straightforward, and it's not really related to circular motion, but usually is lumped in there in most courses. So we're going to cover it now. So far we've been talking about that force of gravity is equal to mg, where g is equal to, on Earth, 9.8 meters per second squared. Now, this is true near the surface of the Earth, but as you get further away from the Earth, you can imagine that the force of gravity is not going to be the same. Like, I'm not going to feel gravity when I'm in a different galaxy, right? The force, there's no way. Otherwise, every planet, every object would be acting a very strong force on me. And because this is really more of an approximation just near the surface of the Earth, we're going to talk about Newton's law. This is called Newton's universal law of gravitation. And actually, this equation is actually somewhat approximate. As a side note, this is Newton's law. This stood the test of time for a long time, but actually is not correct. Einstein actually showed that gravity acts a little differently than this equation. But those equations are so complicated that we still stick with Newton's law for now, because they work. Newton's laws will give you the correct result in most scenarios that we're dealing with. So the equation is equal to, so if I have two objects with mass, m1 and m2, they will attract a force to each other, a force of gravity. So anything with mass will apply a force of gravity. Now, by Newton's third law, whatever forces are being applied in gravity is equal and opposite on the other one. So that's why, both objects feel the force of gravity. Like, when the Earth pulls on me, I pull on the Earth also at the same time. Now, the magnitude of this force is not really mg, especially when you're very far apart. It's actually equal to this equation, g times the product of the masses of the two objects divided by r squared. So r equals the distance between the objects. Two masses. M1, M2 is the mass of the two objects. And g is a gravitational constant. I actually don't remember what g is off the top of my head. It's a it is 6.67 times 10 to the minus 11. And one of the things it has is it has a weird units to sort of make everything work out correctly. Newton meters squared per kilogram squared. The units don't really matter, and you don't have to memorize this constant. This is given to you in most cases, but yeah, that's what you do. So when you're going to apply this equation, you're just going to simply take the distance, and r is the distance between the two masses from the center of each object, because that matters, especially when it comes to the Earth. Like, I'm sitting on the ground. I don't say that I'm 0 meters from the Earth because I'm touching it. It's really the distance to the center of the Earth. Okay, so for example, if I have, the Earth here, and a little rock right here, and this is the center of the Earth, r is going to measure the distance between the center of the two objects. It's not the distance to the surface or the edge of the objects. Okay? And that's pretty much all there is to it. That is the force of gravity. Sometimes how it can relate to circular motion is sometimes the force of gravity is related to satellites orbiting the Earth, and we'll go through some examples like that as we go through some practice problems. But that's how it's loosely related to circular motion.